Hello, welcome back to Fundamentals of Programming course Ch03-192-Basic. Today we are going to talk about operations and libraries. And as you recall, these are something you already learned in the previous course, but I would like to give you a deeper insight about these operations. Okay, so first thing we are going to talk is about some basic operations. For every language, they will provide you a set of operations. Those operations will be divided into several categories. The first category you are going to encounter is arithmetic operators. These things are the most familiar to you and easier to understand. This we have plus, minus, multiply, divide, and modulo. Now, depends on the language you are using. The symbol representing those arithmetic operators may be a little bit different, but they probably looks similar. Well, you may find modulo in some language. They use this one, mod. Okay, like Pascal also. Then you have some other operations called bitwise operators. Okay, now bitwise operator is not popular for every language. The reason is when it is rarely for you to work on the bit when you do programming at a high level. Okay, so why do we need it in this language? I mean C++. Well, if you understand the reason behind this, you will see when you use bitwise operations, you can solve your problem faster. Okay, you can check the flag in your variables, some configuration in your system, and do a lot of interesting stuff that you cannot do with other normal operations, or maybe you need to do a lot of calculation, a lot of step instead. So bitwise operators are something maybe more convenient for a lot of people to work with in when you do programming at a low level. Okay, not just for low level. If you are going to jump into embedded system soon or later, you will see that performing some calculation on the bit is quite normal, right? So here we go. We have the SOR operator, we have NOT operator, we have AND, or this one is the left shift, right shift. This one is left shift. Okay, I'm going to explain about shipping a little bit here. Suppose that I have a variable a with the value let's say 101. Okay, like this one. Okay, 0100. In decimal it should be 4, but this is my representation in binary for you to easier to understand. Now let's say I have a shift to the left 1 bit. That would give you 1000, or in the other words, you will have a multiply with 2. Okay, if you perform A and you do right shift 1 bit, you will get 0010, which means A divided by 2. Okay, straightforward, easy, right? And sometimes we use shipping a lot because it's convenient for some calculation, especially for checking flag and something else. The third category that you encounter here is logic operators. Well, you have NOT, AND, OR, okay, and some other relationship comparisons like greater than, less than, equal. Okay, And the last operations that we have here is the assignment. Well, be careful, because here we have assignment is one equal sign, and a logic operator we have is double equal sign. Well, a lot of people confuse and make mistake when they do programming, because in some code you may find no error. Of course the syntax is correct, but the logic is wrong, so sometimes you have to be careful. Okay, just remind you one last time, don't mix between the logic operator equal with the assignment. Okay, now for arithmetic operations we have some description here. I don't want to repeat it, but well, what I want you to see is look at the example here and guess what you have in the output. Okay, when you try to output 15 divided by 4, what you will get? Well, the outcome here on the screen should be 3, right? The reason is the left operand is an integer, the right operand is also an integer, so you will have integer divisions, and therefore you get 3. Okay, another thing I want you to remember is that the operations that I write here, actually the operators divide here has a higher priority than the operator here. That is why the higher priority operators will be evaluated first, which means here. Okay, don't forget that, right? For the second line, you get 15 divided by 4. Well, what this means, you have the left operand is an integer, but the right operand is a double. Okay, so this division is actually not an integer divisions. In fact, the compiler will convert your first operand into a double before divide, and you have the outcome here is 3.75. It's actually a double number. Okay, the last one is easier to guess because here we have the modulo operations, therefore you will get 3 because that's the remainder of 15 over 4. Okay, now it's time to talk about the assignment operations. Now why do we care about it? Because if you don't understand the basic behind assignment operations, you will miss a lot of informations, and you may encounter some error in the future when you do your coding. Okay, now first, the syntax of the assignment will be the left operand here equal to the right operand. The right operand usually an expression. A variable is also an expression. Any calculation is an expression. Now the important thing that we have to remember about the assignment operation is when you assign the expression into the left operand, the result of this is the left operand. Okay, is so weird? No, I don't think so. Just reasonable in some sense. Okay, so we see the whole statement is an expression. This one is an expression. You will see it later. I will explain. And because you do the assignment, therefore the left operand cannot be a constant for sure, because you want to change the value inside the left operand. If it is constant, you cannot change, right? So this is very reasonable. Now you can see some example here, and the first two lines is simple, so I'm not going to explain about it, but I would like to explain for you the third line. Let's see. Now suppose that I have the following statement: integer a, b, c. I'm doing some job here. Let's say I set a equal b equal c equal 1. What happens here? Well, you will see there are a lot of things happens here. Be careful, right? We have, this is one big statement, right? And in this statement you have one operand, two operand, three operand. Okay, three operators, sorry. So those three operators share the same priority. Now if you have an expression with several operators with the same priority, then the execution order will be from the left to the right. Okay, so if this is right, then the first operators will be the one we evaluate first. So A will be the left operand, and the following here will be the expression. Okay, now I have to evaluate the second expression, and therefore what you see is I have to check the operator assignment operator here, and then B will become an operand and the rest will be the expression, right? Then I have to evaluate this expression by checking the assignment operation here. I will assign 1 into C, and the result of this one would be C. Then back here I will, let's say, assign back to B, and the result of this assignment will be B. Okay, and I assign B back to A, and the result of this is A. And when you see a simple statement like this, it's unlikely that it's operated by just assign ABC by one value, but in fact it's a set of operations from this assignment to this assignment to this assignment. Okay, now if you understand it clearly, you know how it works. Okay, so that's what I want you to keep in mind about the execution mechanism of assignment. This return is important. Okay, well, let's move on. When you declare some variables in your programs, you can initialize its variable by assign the initialization value. The initial value here can be anything you want, and basically we have several ways to initialize the variables. The first way is the simplest way. You just use the assignment operator here and then assign some value to your variables. The second one is not so familiar to you, but I myself use it sometimes. It's called uniform initializations. Okay, the third one is also unfamiliar to you, but when you study about the object-oriented programming, you will see that this initialization is normal. Okay, so we have several ways to assign the value for your variable at the beginning. Here's some example that you may want to take a look. I'm not going to explain about it, it's too simple, right? Okay, there is another exercise that I put on this slide so you can take a look. Basically it's not hard to follow, right? So I'm going to skip that. What I want to give you a note right here is the default type of the constant in your program when you write the code in your source code. how do we interpret those constant? Okay, the default type is sometimes really important. Now, the second question here is that can we assign different type of value to our variables? The answer is yes. We do it all the times, and there's some reason why this is important to understand. We will use some cast operations in the programs, and casting is the most advanced operations you have in programs. Now take a look. First thing I want to capture some idea about the default numbers you have in your source code. Okay, when you compose your source code, when you write some number, by default it is interpreted as the decimal value. Okay, all of you know what is a decimal value is, right? Then sometimes we want to interpret the number not in decimal base, but well, not in 10 base, but maybe octave or hexadecimal. So if that is the case, then there is something you have to note. If you want to represent some number, some octave number, you have to start by 0. Okay, and that should be an octave value. If you are going to start your number by 0 and x, it will be understand as a hexadecimal value. Okay, so let me give you a very quick example. Let's say I may write some number like this: 0, 2, 1. This is the octave value. Then if you want to convert it into a decimal number, it should be to multiply with a plus 1, which is 17. Okay, in decimal base. What about hexa? Hexa means the 16 base. So if you have this one, let's say I have 1E. Okay, then this is the hexa value. The value you have would be 16 multiplied by 1 plus. Now what about E? You will see in hexa base you will have 0 to 9. 10 should be A, B, C, D, E, and F. So E is actually 14. Okay, so this one is supposed to be 30. Okay, so I think this is clear to you. Now when you write a number, a real number like this, the default type you have is double, not float. Okay, double. Why is this important? Because it affects the accuracy of your program a lot. So to answer the second questions, we will discuss about the cast operators. In this language, I mean C++, it provides you the cast operator so that you can convert one type to the other type. And the syntax is the you have the target type enclosed in the bracket here, and then followed by the expression. Okay, so in this example you see I'm casting this double number into integer, and then the whole thing here will be copied to A. Okay, here A is an integer, so I cast A into a float number, and then I plus with a float number. Well, when you write a number, a real number here, and then you end it by a postfix f, it means floating point number, not double. Okay, float number, not double. Here, if I have a statement like this, x will be cast into double and a integer will be cast into double, and then I multiply them and then I assign back to a. If you just write y equal x multiplied with a, it's just fine, because well, the compiler will understand what you want to do, and it will cast your variable according to the operation you are using. For example, here x is a float number, a is an integer, so a will be cast to float. Okay, and x is a float multiplied with a, which is also a float. The result of this one is double. The type of return is double. Okay, and that's easy for you, right? There are some implicit conversions that will be done by the compiler. You don't have to do anything. The compiler will try to infer what to do when you write a statement. Now sometimes you will let the compiler do that job, but sometimes you don't want to. You just want compiler will do what you want. Okay, so here I will do a quick explanation here. If you assign an integer to if you assign an integer here to a float number, there will be a conversion from that integer variable into float before assign. Okay, and if you assign a characters variable 1 byte to a float number, there will be also another implicit conversions right here. Now if you do float number divide by 4 here, then 4 will be automatically converted into 4.0, which is also a float number, and then the division is performed, and then assign back the answer to the variable answer. Okay, and so on. So implicit conversion is nice because it's give you more convenient way to write the code without any explicit conversion, but sometimes it's not good for you. The result of that is unpredictable when you work with autotype. Recall what I have told you a long time ago about autotype, right? It's appear from C++ 11 standard, and of course it's very popular nowadays. When you declare a variable as auto, the variable you declare right there must be assigned. Okay, you cannot declare a variable auto like this. You cannot say I have auto a and this one is invalid statement. In the other words, the compiler will complain to you, say you cannot declare a variable with the type auto like this, because the compiler don't know what type to assign for a, or actually how many space do I need to allocate for a in my programs. The compiler don't know, right? So the thing here is you have to specify a value for that variable at the beginning, so that the compiler will try to interpret, will try to infer what type a should be to contain that value. Okay, and so let's say I write auto a equal 1. Now guess what? It's similar to integer a equal 1, because the compiler now interpret 1 as integer, so it will infer the type of a as integer. If you write alter a equal 1.0, then the compiler will interpret this one as double a equal 1.0. Well, if you want the float number instead of double, but what can you do? You have to understand the default type of the number I told you before. So here, if you say you want a float number, it is better for you to write a equal 1.0 f. It will be interpreted as float a equal 1.0 f. And that is why I told you the default type of number sometimes is really important in your programs. Okay, is it good or is it bad to use auto type? It depends. In my case, in some case when I program with function pointer, auto type is really useful, but sometimes I feel it a little bit annoying because I cannot control the exact type of my data, so I feel like I need to write something more specific. Okay, so it depends on what you are going to do in your programs. Okay, it's neither good or bad, it just depends on how you use it. Okay, the last thing we are going to discuss here is some compile assignments, and I believe that most of you remember this. Okay, it's just a way to write code faster. Like when you do plus equal here, it means let's take the value here plus with some value and then assign back to the origin. Okay, it's just a short way to write the code, and you may find something interesting there. Well, for prefix and postfix, I will go a little bit fast here because maybe you know it. So let's take a look. When you write prefix, it means you are going to do some operations and you return the result of that operations. When you do postfix, you will return the value before you do that operations. Let's say I have the following statement: integer a equal 1.0. Okay, oh, that is wrong, right? No, it's nothing wrong. There is an implicit conversion from 1.0 to 1, which is pretty normal, but this is so weird to write, so I will just put it down. Okay, now let's say I have integer b equal plus a. What it means? Well, here I can interpret the statement like this: integer b equal a plus 1 and then a equal a plus 1. Okay, what it means: when you do prefix operations, the result of that operations is returned first, and then the value of variable will be changed. Okay, in the other words, if you write b equal a plus plus, say is equivalent to b equal to a and then a equal to a plus 1. Okay, so now you know the difference. The value of a always increase after the statement, but the difference is that the return value of that operation will either be plus 1 if you are using the prefix, or itself if you are using the postfix. Now it applies for the incrementing and decrementing too. Okay, so that is all about the prefix and postfix operators. Okay, and I have interesting questions for you. This is weird, but let's say if I bring out A plus 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 B, what will you have? Okay, this question is for you, so I would love to hear your answer later.